Okay, so this is the continuation of scientific notation that we started on Friday, and we're working at it today. I just want to make sure that we have a couple people awake today and they know what we were working on. So basically, when we're working scientific notation, why are we using it? We're using this scientific notation to make our big or incredibly small numbers easier to work with. So if you have a number like this, or like this, not only would they not fit in the calculator, but they would be a pain to continually write out all the time. So they have created a way in which you can represent the same number in a much smaller fashion. And it starts with the expanded notation that we did, and then works into something called scientific notation. Now, scientific notation, we talked about last day, and we did many examples, and it's just taking a number with a base 10 number and then telling how many places I move the zero. So if we look at the rule, which we hadn't done before, maybe we should start there. This is the rule that we actually worked past when we first did it. Now we put it down in writing. So to quickly read the rule, the decimal place is moved to the left or right until it is directly to the right of a single whole number, the first single whole number. Then you can count the number of spaces that it moved and indicate with a positive or negative integer. Moving the decimal to the left, we'll use positive exponents. Moving decimal to the right, we'll use negative exponent. Now that's a big note, but we have to start to make this ours. So we asked today in class, what are the biggest, most important words? What are the directions that we need to single out? Well, someone pointed out that it's directly to the right. That's where we're moving it, to the right of a single whole number. We find that first whole number, and we put the decimal on the right-hand side of that number. Someone also said that left being positive exponents and right being negative exponents was important. And when we actually looked at it with a bunch of examples, I forget who the student was, but they said, you know, we can make just a general rule that when we're working with very large numbers, and we can agree that 23 million is a large number, or if we're working with very small numbers, and decimal 0.00007 is definitely a small number, but if you're working with large numbers, you can say we're always going to use a positive exponent when we count. And similarly, if we're using decimals, we're going to be using a negative exponent. Now that's just a rule, and you might forget and you might get them mixed up, but it was just something that came out today. So to go back to the top, if we're going to use this as our example, I think it's 2 trillion if I'm looking. Millions, billions, no, it's 20 trillion. Got my glasses on. That's obviously a very large number. If we go with what we're talking about on the bottom, that means, well, we're going to have a scientific notation and express it as 10 to a positive exponent. And the directions here says we're going to take it and move the decimal, which you can't see in this number, but it is right there. And we're going to move it until it is on the right-hand side of the first whole number. Now, I'm not going to count by ones. I'm going to count by threes, because these are set up so nicely to count by threes. And then I'm going to just add 1, because the decimal is going to go right there. This number will actually be 2.0, which you don't need the 0 or the decimal. You could just write it as 2. But we need to find out how many places we moved. How many place value columns did we actually move? If we're counting by threes, 3, 6, 9, 12 plus 1 is 13. Now both of these answers are right. 2.0 times 10 to the 13, or 2 times 10 to the 13. I would say that this is probably where you'd want to go, but we're going to do a lot more work where you will actually have a decimal in it, because not all of our numbers will always be zeros. Anyhow, over to the other side, as you can see, in this case, it's a decimal number. It's an incredibly small number. So what we're going to do is use a negative exponent, but we still have to move that decimal. It's going to be moving all this way, and we've got to put it to the right of the first whole number, to the right-hand side. So again, I'm going to count these in threes. And this time I don't have 3. So 3, 3, 3, 3, and 2 ones. So that's 9, 12, 13, and 14. But 14 only gets me to there. I apologize. 14 gets me to there, but I want to go all the way there, so I could have a whole other group. I do have a whole other group of 3. So really it's 3, 6, 9, 12, 15 places that has moved. The decimal will go here. You don't have to write it, but we will. You could also write it just as 9. We're going to multiply by 10, which shows we're using scientific notation once we put the exponent on. And we moved it 15 places to the right using a small number. That will indicate we're going to have a negative exponent. So that's how you do the scientific notation for those ones right there. And we were already doing that last Friday. So what we're going to do now is take a look at this next situation, which is still very, very similar. But in this case, we don't just have a 3, we have a 34. And what I asked you to do is ponder what we're going to do with that. And most people say, oh yeah, we're still going to move the decimal, but they had to decide where it would be. They had to make a decision whether it's going to be 34 or 3.4, because those are not the same numbers. So anyhow, what we talked about today is that still goes to the far right, or to the right of the first whole number. And the first whole number in this is 3, so it will be 3.4. Now all we have to do is figure out how many places we moved it. We moved it 3, we moved it 6, and one more is 7. Just looking at this next question, you know that it's a decimal number, a very small number, which means we're going to be using our negative exponents to represent this. We have to figure out where we're moving the decimal to, and it's to the right of the first whole number, 3, 6, 7, 8. So I know I'm moving this 8 places, 5.6 times 10 to the negative 8. Our third example right here, again, very small number. I know I must be using a negative exponent to represent that in scientific notation. And I know that that decimal place has to move until it is after the first, to the right of the first whole number. So if I want to count again, count by 2s this time, 2, 4, 6 places. That's where the decimal is going to move to. If the decimal moves 6 places, it's going to be 9.087 times 10, and we moved it 6 places to the negative 6. Here we have a very large number, 20,340,000,000. And now it's a large number, so that means when we represent it with scientific notation, we're going to be using a positive exponent. We're going to be moving the decimal place that you don't see at the moment, but we know is there. And we're going to move it all the way till it's to the right of the first whole number. Now that means we're going to move it 3 spaces, 3 more, 3 more, and actually just 1 more. I'll write that down just for people having a hard time seeing that. Anyhow, the new number will be 2.34. You do not write down all the zeros after that, but you do have to write the whole numbers. It's to 10, and we moved it 3, 6, 9, 10 spaces. So that answer is 2.034 times 10 to the 10. Your homework today, or your practice work I should say, brings in a whole bunch of these type of questions, and you just write the answers here. You decide whether it's a very small number or it's a very large number or a very small number. You decide whether you're going to represent it with a positive exponent or a negative exponent from all our practice, and then you just write them out. Then I want you to jump back and go back to what we did a couple days ago, just so keep it fresh in your mind, that you're going to write these 2 here with expanded form, these next 2 here with expanded notation, and lastly the last 2 here with scientific expanded notation. And that's your work today. Come see me tomorrow morning if you have any problems with it.